So I'm currently back in Perth on the west coast of Australia, and with the present COVID-19 restrictions, each time we enter Western Australia we need to undergo 14 days of quarantine, and that means I can't leave this hotel room for another 9 days. It's barely an inconvenience really, it just gives me more time to catch up on various different projects. This is a sundial, and I'm currently running a time lapse with the P900 for one of my subscribers. I'll show you that in a future video. Now, fortunately for this trip, I had plenty of notice, so I was able to pack one of my telescopes, and that is what I used for some of the footage you're going to see in the rest of this video. So the point of this video is very straightforward. It's relating to the visibility of the Himawari 8 and 9 satellites from different parts of Australia. As you have seen on my channel previously, during time-lapse footage of satellites, the Himawari 8 and 9 satellites are clearly visible from Sydney, Australia. Last night I was able to see them with my telescope from Perth, Australia. That is the other side of the continent, 1,700 plus nautical miles, over 3,200 kilometres away. So as you can understand, this is a major problem for those flat earthers who believe these satellites are just balloons. So what do they tell us about Himawari 8? Himawari 8 is a Japanese weather satellite, the 8th of the Himawari geostationary weather satellites operated by the Japan Meteorological Agency. So it's a geostationary satellite, and that means it has to be in orbit above the equator. Down here we see some of the orbital parameters, and specifically the longitude. It is located on the equator at 140.7 degrees east longitude. And here we can also see the satellite's altitude. The perigee is 35,791 kilometres, and the apogee is 35,795 kilometres. So almost perfectly circular. There's only a 4 kilometre difference, which is a very tiny percentage of the size of the orbit. The altitude is quite critical to obtaining that geostationary orbit, and as I said earlier, it needs to be over the equator. If the satellite was closer than this optimum distance, it will orbit faster than the rotation of the Earth. If it is further than this distance, it will orbit slower than the rotation of the Earth. So this is Google Earth, and I have drawn a line from Sydney Airport to Perth Airport, which is a route I fly frequently. The distance, rounded to the nearest nautical mile, is 1,774. In kilometres, again rounded to the nearest kilometre, 3,285 kilometres. Now they tell us that the Himawari satellite is located at 140.7 degrees east longitude, right over the equator. This is the 140 degree longitude line, so the position of the satellite is 35,000 kilometres above this position. At that altitude, it is no surprise that it could be visible from Sydney, Australia and Perth, Australia at the same time. Significantly, from Sydney, Australia, we will be looking to the left of due north to this position, and from Perth, we will be looking to the right of due north. If the satellite was simply a balloon at a much lower altitude, it could not be visible from Sydney and Perth at the same time, appearing completely stationary in the sky. So this is Sky Safari Pro 6, which is one of the astronomy programs that I use. It allows us to see the position and orientation of the stars from any location on Earth in real time or at a specific set time. At the moment, my location is set to Sydney, Australia, and here we see the Himawari 8 satellite to the left of the due north line, exactly as we would expect. If I change that location to Perth, it should now appear to the right of north. And that is exactly what we see. Here is Himawari 8 to the right of north. This matches the expectation from Sydney, Australia and Perth, Australia, if the satellite is indeed above the equator at 35,000 plus kilometres. So we know the distance between Sydney and Perth in Australia, and the software gives us a precise angle from each location to the Himawari 8 satellite. From Sydney, Australia, the azimuth is 341 degrees and 32 minutes. The elevation is plus 49 degrees and 3 minutes. From Perth, the azimuth is 41 degrees 9 minutes with an elevation of 44 degrees and 9 minutes. So given that information, in addition to the distance between Sydney and Perth, I'd like flat earthers to please calculate how high they believe the Himawari 8 satellite or balloon actually is. Please show us your calculations and tell us how high you think this balloon is. So this is the footage from the telescope, 12-second exposures compiled into a time lapse. The washed out appearance is primarily due to the heavy light pollution in the area. In Sydney, we also have light pollution, but my larger telescopes are each fitted with a light pollution filter, so the sky will appear a lot darker. However, this small telescope does not have one, but we still see all the information we need. You can see this brightest star and Himawari 8 and 9 satellites, and also these two stars. If we go to Sky Safari Pro, here is that star, which goes by the designation of HIP 106362, and these are the other catalogue numbers. And we also see these two smaller stars. Now if you notice the time, I've got 14:03:26 UTC. That is exactly the same time that we have here in the time lapse, and you can see the relative position of the satellites to that star match perfectly. So here we see 5 satellites. The first one is Himawari 9, then Himawari 8, followed by these 3. Now they actually appear brighter in the telescope image. I have shown this group of 5 satellites before from Sydney, and don't get confused because the image is inverted. It's just how I have the camera oriented on the various telescopes. Himawari 9, Himawari 8, followed by these 3. In this footage, we have Himawari 9, Himawari 8, and then we see the others coming into view. There's the first one, and when I see the second one, I stop the tracking on the telescope, and at that point, the satellites become stationary. Himawari 9, Himawari 8, followed by the other 2, and the third one is just off screen. Now, unfortunately, we get a little bit of cloud, so it washes completely out, but as the time lapse continues and the cloud clears, we can clearly see those satellites with the star field moving. So once again, the question I have for flat earthers who believe satellites are balloons is, how can I see the same satellites from Sydney and also from Perth more than 3,200 kilometres away? Here they are in Sydney, and here they are in Perth. How high are these balloons supposed to be? And I'll just leave you with some footage recorded on the phone last night as I was filming this. So what we're looking at is Sky Safari, and this is Himawari 8 and 9. They're just about to go past this bright star, and that star is this one in the telescope, and then you see these 2 stars together, which are just one of the highlighted ones here. So here we see Himawari 8 and 9 coming into view. What I'm going to do is just let them travel to about here, in the frame, and then I'm going to pause the tracking. So you can see already it is just matching beautifully with the prediction in Sky Safari. There's Himawari 8 and 9. I'll show you the telescope itself. So this small star here is the one that I've highlighted in Sky Safari. And it's running a 12-second exposure. You can see that here. So as you can see, the reality of what we are observing with the telescope is matching the prediction perfectly in Sky Safari. They're just moving past that highlighted star, and that is exactly what we're seeing. So at the moment, the telescope is tracking, and very shortly I'm going to turn off the tracking, and that means the satellites will appear stationary and the star field will begin to move in the frame. So here we can see one of these satellites just coming into view. And you can see it's going past this bright star. Again, exactly as predicted. So when we see the second one, I'll pause the tracking on the telescope. And there it is. So let's just pause the tracking on the telescope. Pause. Now what's going to happen is those geostationary satellites will become stationary in the time lapse, and the star field will begin to move. And there you can see that is exactly what we are observing. The two Himawari satellites, and these two are following. So what we've done now is essentially lock onto the satellite, and we've done that by stopping the tracking on the telescope because these are geostationary satellites. So we can see these same satellites from Perth, Australia, that I see in Sydney, Australia. The telescope is pointing to the east of the meridian. In Sydney, I have to have it pointing slightly west of the meridian to see the Himawari satellites.